We recently received an NIH grant to study cellular immunity to influenza virus infection. And respiratory infections are a very serious health concern, and every year millions of people die from these infections, particularly in underdeveloped countries. Even in the United States, we get as many as 40,000 deaths each year, mostly in elderly people that are very susceptible to mild strains. Our current vaccines are somewhat effective, but they have to be changed every year because the virus keeps mutating. As a result, we would like to generate a different type of vaccine that targets the CD8 T cell response, which can recognize internal parts of the virus and is highly conserved. The goal of the vaccine is to introduce memory T cells which respond rapidly to reinfection. For many years it was thought that memory cells circulate around the body, but recently it's been found that some memory cells, called tissue-resident memory cells, will actually stay in the infected tissue until a new infection. These memory cells work a bit like security guards in a bank and guard the door where the virus comes into the body. The goal of my lab is to try and understand how to generate this type of memory cell by vaccination. And we're using soluble molecules called cytokines to try and change the adhesion molecules on the memory cells so that they will actually localize to the correct tissues. If we can do this, we may be able to induce immunity to many different strains of influenza virus and potentially create vaccines that could be useful for treatment of many different pathogens that also enter the body via the lungs.